Guys, in this video we are going to see how to convert numbers from binary to hexadecimal, hexadecimal to binary, and also hexadecimal to octal, octal to binary, and binary to octal as well. So we are going to see how to do the shortcut, how to do it very quick. So first let's look at an example of how to convert a number from hexadecimal to binary. So let's say we have a hexadecimal number given by AB73C5, and the base of the hexadecimal is 16. And hexadecimal number can be for a hexadecimal, we can convert this one easy to binary by using 4-digit method, which is 8421. If you wonder how did we get this number, it's basically like if you have 1111 in a binary system, the location of the first number is 2 power 0, then 2 power 1 second one, and the weight of this number is 2 power 3, and then 2 power 4. So 2 power 0 is 1, 2 power 1 is 2, 2 power 3 is 8, and then this one should be 2 power 2, and this one should be 2 power 3. So 2 power 2 is 4 and 2 power 3 is 8. That's how we got this one. Okay, so we take 4 digit for each number, because hexadecimal, 1 digit of the hexadecimal is 4 bits. Okay, so that's why we need to have 4 digit number to represent each hexadecimal numbers. So let's apply that one. So first I put the 8421. Now if I apply 8421 for the, so we want to convert this one to base 2. So if I apply 8421 to 5, you have to see, I put it right here, so we have enough space. I put 8421. So first we want to convert this 5 into hexadecimal. So we need to ask what numbers will give us 5. 4 and 1 gives 5, so we put 1 for this and 1 for the 1 for the 4, 1 for the 1, and others are 0. So this one is equivalent to 5, and I put that number here, 0 1 0 1. And then C, hexadecimal, it is like 0 to 9, and then after that it goes to ABC. A is number 10, B is number 11, and C is number 12. So this is number 12 right here. So for 12, what we need an 8 and a 4. So for 8 and 4 we put 1 1, and others are 0. So this is equivalent to C, and then I put that number right here, 1 1 0 0. And then 3, for 3 we need a 2 and a 1, others are 0. So 0 0 2 and a 1, this is equivalent to 3. So I put that one over here, 0 0 1 1. And then for 7 we need a 4, 2 and a 1, and 8 is 0. So this is 0, and then 1 1 1, this is equivalent to 7. So I put that one over here, 0 1 1 1. And then for B, A is 10, B is 11. So for 11 we need 8 and a 2 and a 1. So 1, and we don't need the 4, so for that one we put a 0, 8 2 and a 1. So 1 0 1 1, and this is equivalent to B, and we put that number over here, 1 0 1 1. And then A is a 10. For 10 we need an 8 and a 2. So this is 1 0 1 0. This is equivalent to A. So I put that number over here, 1 0 1 0. And this is the final answer. This is how we convert a hexadecimal to binary easily. Okay, there's a longer method. You can convert this one to decimal and then divide it by 2 until you get 0. That's going to be very, very long for this much big number. So this is a very shortcut. This is a shortcut. You have to just know this system. Okay, now let's look at an octal. Let's say we have an octal number given by 74325, and we know for the hexadecimal it is like 1 to 15. For the octal it's 1 to 7. And here if you add this together, you see 8 plus 4 plus 2 plus 1, which is 15. But for the octal, you see we need to have maximum number of 7, because whatever the base we have, if it's base 16, the maximum number is going to be 15. If it's base 8, the maximum number is going to be 7. If it's decimal, maximum number is 9. It's going to be 1 less than the base always. So if it's a binary, it's always 0 1, it doesn't go to 2. Hexadecimal, it goes up to 15 only, it doesn't go to 16. For the octal, it goes up to 7 only, it doesn't go to 8. For the decimal, it goes up to 9 only, it doesn't go to 10. Okay, so it's always 1 less than the base. So here the base is 8, so it's going to be 1 less than that. So here you see, if I just remove this 8, 4 to 1, we can just take these 3 and that make up to 7. So 4 to 1 system. So for the hexadecimal, we use 8 4 2 1. For the octal, we use 4 to 1. So we only need 3 digit. Okay, 4 to 1. So we apply similarly 4 to 1 for each number. So here if I start first 5, what makes it 5? So this is base number 2. We are converting to base 2. So what makes it 5? We need a 4 and a 1. So 1 0 1. Okay, this is equal to 5. So I put that one right here, 1 0 1, and then we need a 2, which is 0 1 0. This is a 2 0 1 0, and then for the 3 we need a 2 and a 1. So 0 1 1 0 1 1, and then for the 4 we need a 1 for the 4, and the others are 0 1 0 0. So 1 0 0, and then for the 7 we need 4 and a 2 and a 1. So that is 1 1 1. So you see, this is 7, this is 4, and this is 3, and this is 2, and this is 5. 7 4 3 2 5. This is the conversion. Okay, now let's look at how to convert from binary to hexadecimal. I go to the next page. So let's say we have a binary 1 0 1 1 0 1 1 1 1, and then 1 1 0 1. Okay, this is a base 2, and we want to convert this one into hexadecimal. Now similar approach. For the hexadecimal, we know that each number is 4 bits, so we have to divide each number into 4 digits of binary. 1 2 3. Okay, so this is how we get, and then now we apply 8 4 2 1 method. 8 4 2 1, and then first one is 1 0 1 1 0 1 1 1 0 1. We have an 8 and a 4, 12 plus 1, which is 13 in hexadecimal. We know that 10 is a B is 11, and then C is a 12, D is a 13. So this is a D. Okay, and then 0 1 1 1, we have a 4 and a 2 and a 1, which is 7. So we just put 7, and then 1 0 1 1 1 0 1 1, we have an 8 and a 2 and a 1. 8 plus 2 10, 10 plus 1 11. We know 10 is a A and 11 is a B, so this is a B. B7D base 16 is the conversion of this binary into hexadecimal. Now let's see how to convert a number from binary to octal. So let's say we have a number 1 0 1 1 1 1 1, and then 0 1 0 0, and then 1, and then 1 1 0 0 1, and the base is 2. Now for the octal, we know that for the hexadecimal it's 8 4 2 1. For the octal it's only 4 2 1. So we need to, because each of the octal number is 3 bits, so we need to pick 3 numbers from binary. So we have to separate by 3. So we check first 3, second 3, third 3, fourth 3, and then fifth 3. And if we don't have a 3, we put a 0 in front of it. So that's why you always start from, like, if there's no fractional value, if there's no fractional number, you always start from, like, for the fraction, if there's no fractional number, you always start from right to left. If it's a fractional number, you start from left to right. Okay, because if you start from right to left, and if you don't get 3, like for example, let's say this is only 2, then you put 1 0 on the left and make it a 3 digit. But you cannot do in this side only after the fractional. For example, if I have 1 1 0 1 1, then this side you can put 0, but for this one you can only put 0. So after fraction in the right side, before fraction is on the left side only. Okay, so you have to remember this. Okay, let me try this again. Let me make sure I don't miss any number. So I'm dividing by each by 3 again. So these 3 first, these 3 second, and these 3 third, and then these 3 fourth, and then these 3 fifth, and then if there's no 0, then I put a 0 for it on the left and make it 3. Okay, now we can go and find each number. So 0 0 1 is 1. Okay, 0 0, see, we just put 0 here. 0 0 1, which is 1. 1 1 1, which is 7. And then 1 0 0, which is 4. And then 1 1 0, which is 6. And then 1 1 1, which is 7 again. And then 0 1 0, which is 2. So this is the octal conversion of this number. Okay. So let's say we have a fractional point. Let's look at the fractional point. Let's say we have this one, 1 0 1, 1 1 1, 1 0 1, and then 0 0 1, point 1 1 0 0 1. Okay. Now we know that after the fractional value, we start from right to left. So we start from here and go all the way to left by dividing by 3. So let's put what we want to do. We want to convert this one base 2 into base 8. We want to find out the equivalent base 8 of this one. Okay, so here we have all numbers separated. We have enough number to divide by 3 each, so we don't have to worry about this side. But if I go to after fraction, we have to start from left to right. So I start from here 1, and here I don't have enough to make it 3, so I put a 0 on the right for this. If there's enough in this side, we put in the left, but if there's not enough in the after the fraction, we put in the right side. Okay, now we make it 3, and then again 4 to 1 system. So 0 1 0, which is 0 1 0, which is 2, and then 1 1 0, which is 6, and then 0 0 1, which is 1, and then 1 0 1, which is 5, and then 1 1 1, which is 7, and then 1 0 1, which is 5. So 5751.62. Okay. Now let's look at another example. Let's say we have a number given like this. We have a hexadecimal number which is given by AF3.E4C, and we want, this is a base 16, and we want to convert this one into base 8. The shortcut method is basically you convert this one first into binary, then convert into base 8. So if you convert this one into binary, again 8421 method to convert into binary, we know that A is 10, so we need a 1010, so we should put 1010 for it. And then F is 15, which is all 1 1 1 1 1, and then 3 we need 0 0 1 1 0 0 1 1. And then for the E is 14, so which is 1 1 1 0 1 1 1 0, and then 4 is 0 1 0 0 0 1 0 0, and then C is okay, so A is 10, B is 11, C is 12, so C is a 12, which is 8 and a 4, so 1 1 0 0. So this is 1 1 0 0. Now to convert this one into, this is a binary, now convert this one into octal, we need to separate by 3, and we know that before the fractional point we start from right to left, so we divide by 3 from right to left, and then for the after the fraction left to right. So we have enough exact number that dividing by each by 3, so we don't have to add any zeros to this, we can straight convert. So for the binary to octal we use 4 to 1 method, each one, so this is like there's a 4, so which is 4, so this is 1 1 1 0 0, so there's 4 here, so this is a 4 on the right side, and then 0 0 1, which is a 1, and then 0 0 1 again a 1, and then 1 1 1, which is a 7, and then 0 1 1, which is a 3, and then 1 1 0, which is a 6, and then 0 0 1 1, which is a 3, and then 1 0 1, which is a 5. So 5363.714 is the conversion of this hexadecimal to octal. This is octal conversion. Okay, that's it for this video. I hope you guys found this video helpful. Thanks for watching.